Okay, please find seats, please. It's time to begin. Could someone close the doors in the back? Okay, so this is SIDROPS. If you had a different destination in mind, please disembark at this time. Oh, clicker. So this is the note well. If you plan to participate, please make sure you are aware of these rights, privileges, and most importantly, responsibilities for your contributions. Secondly, please treat each other very well. Please be respectful. It's okay to disagree with an idea, but that doesn't mean the person with the idea you disagree with is not due respect. For the people that are in the room, please make sure you join the online tool. This is how the blue sheets are kept. And for people who are remote, please make sure that you are muted and not streaming your video unless you're wanting to talk. And use of a headset is strongly recommended. Whoops. The stop wasn't updated. We're not in Brisbane. So this is the agenda. We want to tell you how we organized it. Adopted work is first, and it goes down through the work that is under consideration for adoption. That was quite intentional. We think we can do all of these presentations in the time allowed. If that is not the case, we will schedule a virtual interim to deal with anything we did not get to. There's more. Okay. So the first question is, do we have a note taker? We can't proceed till we have a note taker. Thank you, Jeff. Evil. No. Bad and evil are very different. But thank you, Jeff Houston, for volunteering to take the notes. You're going to do them in the Etherpad? Yeah. Thank you. All right. So is there any agenda bashes? Okay, hearing none, we'll proceed with this agenda. And Sophia is first.
I did upload.
Yeah, it's here. I need to find it. Why is it not? That's not what I want. It's not switching. All the slides. What? I don't know what that means.
The joys of being the first presenter. Okay. Good afternoon, everyone. I'm Sophia. I'm the program manager for the NRO RPKI program. in case you haven't heard from me yet, and I have the pleasure to be the first presenter this afternoon. My main goal for today is to share what we worked on last year and what we are aiming for this year. But for those of you that may not have been present in my previous presentations, I will also do a brief introduction to the RPKI program. So the purpose of the NRO RPKI program is to provide a more consistent and uniformly secure, resilient, and reliable RPKI service. And the reason why we think this program is important is that the RIRs already have, under the umbrella of the NRO, coordination groups for different areas of the work that they do. But this program creates a space for more structured coordination and collaboration in the space of RPKI. We are aware that there's some differences, inconsistencies in the way the RPKI system has been implemented by each of the 5 RIRs, both in the back end and the front end. And also that there are some RPKI challenges or concerns that need to be addressed in an aligned, coordinated way by the 5 RIRs. So one of the most important pieces from my presentation today that I will be keeping very short is what we worked on last year. I shared last year that one of our objectives was to have a better understanding of what a single global RPKI system would look like. And in the context of that objective, we started by documenting a baseline of what currently each RIR is offering in terms of services, RPKI services and features. You also may have heard from me last year inviting network operators interacting with more than one RIR to participate in a survey and then some interviews. So that user research helped us understand a bit better what are some of the barriers that they are experiencing or challenges. And then we also did some work to document the problem statement of the concerns around the current trust anchor configuration, and we started exploring what solutions we could offer to improve the current situation. Then we also had an objective around robustness. We want to better measure the robustness of the RPKI system as a whole. And we started last year by documenting what we think are the key aspects of robustness, and we had input from each of the 5 RIRs to understand how each of them are implementing these aspects on their side. And then where most of my work happens is keeping the technical community informed and engaged, presenting updates about the work we do, but also responding to any community input in a coordinated way. And I will, at the end of this presentation, provide an email address in case anyone wants to reach out to us. For this year, we have agreed on continuing work from last year and the 2 main objectives. The third one is, again, keeping the community informed and engaged. But the first objective is making progress towards improved transparency, robustness, and security of the RPKI system. So this is in the back-end side. And the main piece of work under this objective is in continuation of the work we did exploring the current concerns around the trust anchor configuration. We are now discussing a solution to communicate constraints to what resources are being managed by each RIR, and we will share more with this group once we've made some progress. Our second objective is around more on the front-end side of the system, increased consistency of the RPKI system user experience. And in continuation to the user research we did last year, we will be doing a more formal gap analysis. But I think the most important piece of work under this objective is probably agreeing on a core set of services and features that all RIRs can commit to offer by a certain date. And I will be, again, updating everyone on progress as the year goes by. If you want to learn more about the RPKI program, there is a webpage under the NRO website where there's more information. And we have 4 blog posts from last year where you can learn more about the objectives we set out, some progress we made, the user research, and then there's also a wrap-up blog article from December where you can read a bit of a more detailed summary of what we did. And as I mentioned, we would really like the technical community to reach out to us, share any barriers or obstacles that you can think of in the space of RPKI, of course, that can be solved or improved by better coordination among the 5 RIRs. So please, if you want to share anything in that space, reach out to us through that email address on the slide. And that's it from me. Thanks everyone for your attention. As promised, I would keep it very short. I think we can take a couple of minutes if there's any comments or questions. I was so clear. Thanks so much, everyone.
Thank you. Can get started. So good afternoon, everyone. I'm Sriram, and my collaborators on this work are Oliver and Maria. Before I get into this particular topic of verification examples for the ASPA and the unit tests, let me mention quickly the status of the ASPA verification draft. We have uploaded a version 21, which primarily was to include or reflect Maria's comments. Authors had an extensive discussion with Maria on the SIDROPS list, and we resolved those comments, except for a few wording tweaks that Maria and myself and Alexander are currently doing. So that will get done this week, I think. And we'll upload a version 22 if necessary. So with that, I think the verification draft would have addressed all the outstanding comments from the working group. So that's the status of that. And in terms of the implementations, there is the NIST BGP-SRX implementation, OpenBSD implementation, Maria's BIRD implementation, and also a newly learned free RTR implementation. So there are 4 of them. And one great news is that with regard to the verification examples and unit tests that I'm going to talk about, 2 of the implementation teams, Maria's with BIRD and the free RTR folks, they have both reported that they ran these unit tests against their implementation, and they worked perfectly, passing all the unit tests here. So that's great news. So with that, getting into the topic in front of us, so we start off with providing a topology, an example topology, where some of the so A, B, C, D, etc. are ASS, autonomous systems. Some of them don't have ASPAs, others have ASPAs. So we list the ASPAs, and next slide, please. Oh, I can change. Okay. Yeah, thank you. In table 1, we list, looking at that topology, we pick a set of receiving or verifying ASS, and we pick a set of different paths of different lengths. These paths start from some origin AS and they reach up to the verifying AS. And then we provide the computations, some of the parameters that the upstream path verification algorithm would compute, the max upramp, the min upramp, for example, and then based on that determining the result of the upstream verification. So this table provides 9 tests or unit tests or examples along with the upstream verification result. Next slide, please. So we take a couple of those rows from that table, and we work out the detailed verification for those specific examples. And that's what this slide shows, computing the various parameters based on the algorithm, the upstream algorithm in the verification draft and getting to the result. So for folks who are just trying to understand the verification draft, this can be helpful if they look through this and it matches their understanding of the algorithm in the draft. That helps. Next slide, please. So this is just another example, another row from the table. We are again working out the example with showing the various steps. Next slide, please. So this table is concerning the downstream path verification. So there are a set of examples here. Again, a verification AS is picked and a path of a variable different lengths are picked. The paths start from the origin AS and reach up to the verifying AS. Now, in this case, there are more parameters to compute in running the verification algorithm. We show what those four different parameters compute to, and then based on them, determining the result of downstream path verification. So again, these are test examples for a reader to take help from, to figure out the algorithm or to confirm their understanding of the algorithm. And these also serve as unit test cases for an implementation. Next slide, please. So this is, again, like working out the details of one of the examples in table 2 for the downstream path, showing the various steps. And on the next slide, So similarly, like another example from table 2 is worked out here. So hopefully this helps the readers of the verification draft and more importantly, the implementers to test their implementations. And like I said, it is wonderful that we have both the BIRD implementation and the free RTR implementations. Both of them have confirmed that they have reported that their implementations work perfectly against these unit tests. So that's great news. And next slide. That's it. That's my last slide. And we are going to maintain these examples external to the draft so that people can provide inputs and we can make any updates to these examples as needed. But we do reference the external website where these set of slides can be found. We can even reference the SIDROPS, this presentation now in the draft, so people can get to this easily. So that's all. Thank you.
Any questions for Sriram? Okay, hearing none. Thank you.
Great. Thank you.
Hello everyone, I'm Ying Su from ZGC Lab in Beijing, China. In IETF 121, we submitted draft RPK repository problem statement 00 and analyzed three problems of RPK repository. In this IETF, we submit draft 01 and introduce the requirements for an enhanced RPK repository. In next IETF, we plan to present an enhanced RPK repository architecture. Let's review the problem. In current RPK repository, RPK authority controls RPK object signing, storage, and management. It may lead to 3 problems. First, each RPK object only stores in the Unicode PP running or designating by the RPK authority. So any PP's failure will prevent RPs from obtaining its stored RPK objects. Second, the number of PPs and RPs are expected to increase with the further deployment of RA and RV. And so the growing connections between PPs and RPs will prevent RPs from obtaining update ROAs quickly. Finally, as described in RFC 8211, RPK authorities can unilaterally delete, corrupt, modify, or revoke any RPK objects without consent from subordinate INR holders. Based on the above analysis, we think separating RPK repository from RPK authority and design an enhanced and independent RPK repository may be helpful. The RPK repository may implement an access mechanism that can effectively limit the growing number of nodes. The repository nodes can be running by 5 IRs, state-running institutions, large ISPs, and so on. They may have good reputations and reliable service platforms. Then in the enhanced RPK repository, each node equally provides data storage service for all INR holders. It may solve the problem of pro-scalability. Then INR holders can first select the node running or designating by RPK authority to host RPK data, but they are also free to choose other nodes to host their RPK data backups. So INR holders can actively control the data storage and management. Therefore, they can solve the problem of malicious RPK authority. Then it is obvious that in the enhanced RPK repository, a single RPK object can be replicated across multiple repository nodes. So the single point of failure will not prevent RPs from obtaining update ROA data. We summarize the requirements for the enhanced RPK repository. First of all, it should be compatible with the current RPK repository and allow the RA deployer to freely choose between two RPK repositories. Second, it should achieve truly distributed data storage and enable a single RPK object to be backed up across multiple nodes. Thirdly, it should prevent the unlimited growth of the number of PPs. Finally, it should actively defend against RPK authorities' malicious behavior. To summarize, as the industrial's best practice, RPK should provide secure and reliable service to INR holders, to RA deployers and RV deployers. So we think enhancing the RPK repository may be a feasible solution. We are seeking collaborators to co-design an enhanced RPK repository system. If you are interested, please contact us. Thank you.
Questions or discussion?
Job Snyders, would you mind going back 2 or 3 slides?
One
more, please. Yes.
This one.
Yes, perfect. Thank you. So as I understand the technology stack, already today, the resource holder can choose where they want to publish their objects. So I am not entirely sure what the suggested enhancement is, because this slide reflects what is already today available to resource holders. So for example, I am delegated resources by RIPE and CC, a bit of IPv6, and I can choose to host the ROAS myself, or I can use RIPE's publication as a service or someone else's service. So in other words, this already exists. So I'm not sure what problem is addressed.
But as I know, the RPK authority signs certificate to the subordinate INR holders, but the storage of the certificate is determined by the RPK authority. Maybe the RPK authority can put it in one repository node or another repository node, but it controlled by the RPK authority. It may have some it may have some maybe the certificate can be easily revoked or modified by the RPK authority.
But revocation is a matter unrelated to publication. This is a hierarchical system, so my issuer has full control over me because it is my issuer. This is the nature of the PKI.
Oh, okay.
And the issuer on the certificates they sign, they will indicate where the products I sign as subordinate subject will be hosted. And I inform the authority I will be hosting my products here or there or there. So back to the RIPE NCC example, the resource certificate that lists my resources is hosted on RIPE NCC's infrastructure because RIPE NCC chooses to host the certificates they issue to be hosted on their infrastructure. But I, as resource holder, get to choose where I host my ROAS or ASPAS or whatnot. So I think the divide, who gets to choose where they host things, there already is full flexibility in the current system. But thank you for the presentation.
Thank you.
Tim?
Tim Ruijsels, RIPE NCC. Indeed, what Job said. Also, many of the RIPE NCC members, for example, and other RAR members and NIR members choose to use CAs that are hosted at the NIR or RAR, and then that organization also takes care of publication. I'm not sure that there's much use in that organization then publishing the content somewhere else, because the user already has a very strong dependency on the user interface to create the ROAS there. So I'm not sure that that would give you anything in real terms, but if you run a delegated CA yourself, you can choose where to publish, just like Job said. In addition, on the last slide, or not the one that says questions, but the one before, you listed something about recommendations to mirroring and availability of publication servers. I would like to ask you to have a look at the publication server best current practice document that we've been working on. The authors actually feel that it's close to last call. We haven't asked for that yet, but we might do soon. But I would urge you, please read that and have a look if there's anything that you see in there that, you know, you would like to contribute to, because that talks about how we can ensure that the availability of the publication server is, and the repository is as best as it can be. If you're thinking about things like mirroring or multiple publication points, that's a much larger discussion, and that's not something that we can solve today, but that might be something that we want to look at in the future.
Oh, thank you.
This is Minqing Michael from and
Talk to the microphone, please.
And sorry?
Yeah, talk
okay,
to the
perfect.
microphone.
So basically, my company may answer, you know, the question from Job, from my understanding that right now the architecture of RPK is like 4 layers that go straight north-southbound, right? So the idea is that right now we seem kind of no, you know, collaboration between the PP points. So if we can do that, you know, from kind of help each other to attest for other PP or to provide a backup service for other PP, might be better, you know, provide better, you know, resilience for the whole system. That's the point. But again, my point of view is that we may not to redact the number of PP, just provide some, you know, east-west, you know, collaboration, you know, that kind of relationship. That's my point. Thank you.
Randy?
Randy Bush, Arcus, and IIJ Research. Originally, it was hoped that people would do some very serious scaled publication points, i.e. the Google DNS approach, so that the reliability of publication points was less of an issue than it is today. That can still happen. And to repeat a song I've sung many times, you would be less worried about the reliability of a publication point at the moment if your relying party software was not hanging on hard to reach publication points, but instead used fork and exec.
Thank you.
Job Snyders. In response to Mr. Bush, I'm not sure there currently is a validator implementation that hangs on a PP while not progressing other PPs. Like RPKI client, Routinator, and Fort download in parallel. So it could be worse than it currently is, I guess, is what I'm saying.
It could always be worse. Okay, the queue is empty.
Thank you.
All right, thank you. We're going to do Yang data now.
Hello, everyone. Am I audible? I suppose it's fine, right?
Yes, we hear you.
Thank you. So myself, Jishnu Roy. I'm from Juniper Networks, and on behalf of my co-authors and authors, I'll be presenting the changes and updates that we have brought about in the Yang data model for RPK router protocol. So ideally, like the intent behind this development is that we want to address the telemetry enhancements, improvements for the RPKI to RTR protocol as well. Next slide, please. Okay, so ideally we are addressing the Yang models for RPKI as mentioned, and instead of defining a single Yang model for the entire stuff, we have divided it into two Yang models, one primarily addressing the session-specific management, that is the IETF RPK RTR Yang, and the other one will be addressing the RV or route validation records, ROA records related data that will be addressed via the IETF RPK table Yang. So this draft that we see in the updated version, previously we had few inclusions for the BGP specific RPK parameters in this draft. Majorly, for example, the validation statistics, like the number of validation state valid, invalid, or known routes in BGP. That stuff we have pulled out from the current version, and we have placed it in a different draft, namely IDR BGP RPKI Yang, that will be addressed in the IDR forum. And the current draft is mainly consisting purely the contents of the RPKI table and RPKI session-specific data. Next slide, please. All right. So as mentioned, the entire Yang has been divided into two sections. One is the RPKI table Yang, and we have augmented the RPKI RTS RTR Yang, which is consisting of the session-specific parameters under the control plane hierarchy. There is some changes with respect to the naming conventions. IETF RPKI RTR Yang previously consisted of the term cache servers for defining the sessions, which has been updated to sessions, and within that there has been some modification on the various containers that we will be discussing shortly. There are 4 of the new containers that are introduced, specifically connection data, protocol data, PD counters, and error PD counters. The details will be shared the following slides. Next slide, please. All right. Ideally, we have introduced for the RPKI RTR Yang, we have introduced the authentication specific parameters, majorly which will be the TCP/IP, MD5 or SSH rated parameters included, other than the regular server address, server port, local address, and others. And for the 4 top level containers, majorly the connection data, protocol data. Connection data majorly will be consisting of various timestamps, like for various messages that is received in for that particular session. Number of flaps that the session has encountered, up or down status, these will be tracked via the connection data container. Protocol data majorly will be consisting of various counters, like how many message, for example, like any reset query or like serial queries, like how many counts we have received from that particular session, that will be tracked via the protocol data container. And the PDO counters will be tracking the number of reset queries or various session specific message that we have. The counters and the timestamps will be mentored by the PDO counters. And as the name specifies, error PDO counters will be tracking the error message that is received via for that particular session of the cache server to the router. Next slide, please. Okay. For the RPKI table Yang, the other one, we have tried to elaborate on the route attestation records, RP records that we have, majorly via the ROA table that will be consisting of the IPv4 and v6 containers, mentioning the ROA list, total records, records added, deleted, and the specific information. Along with that, the router key table and ASP table will be tracking the other details with respect to the route validation data we have. Next slide, please. Okay, so majorly the concern why we are trying to bring this up is that with the AI involvement, there will be requirement for a large amount of telemetry data to be streamed, and to support that, we are bringing in the Yang versions for RPKI to be introduced. So we request you to review more and have comments so that we can improve the draft, and any queries you can go ahead with. Yeah, that's all.
So when do you think this document will be mature enough for a call for adoption?
We are planning to place it if we just didn't want to place it at the first go itself after the separation of the RPKI table and the RPKI session Yang. But yeah, we are ready to place it for adoption soon after this.
Okay. When you think you're ready, please ask on the list.
Hey, Jishnu, this is a pretty good start with the Yang model. The one quick question I have for you is that, and this is Kevin Patel, Arcus. One quick question I have for you is, are you also planning to incorporate protocol side policy changes based on the RPKI state, or you're going to keep that out?
That's a very good point, Keyur. We'll definitely list that up. And currently we have not planned yet, but yeah, it's a very good suggestion, and we are queuing it up to be addressed.
Rüdiger Volk. I have a small nit on the Yang model that you showed. I very much sympathize with your idea of having separate V4 and V6 ASPA data, but I understand I have been overruled by the working group some time ago. So the working group unfortunately decided to be AFI ignorant, yes. And so the IPv4, IPv6 branch there should be moved away.
I take that. Rudiger, we'll work on that, and maybe like we'll be updating in the mailing chain. You can have your comments there as well once we update. Sounds good.
I see the queue's empty. Any other
Thanks,
comments?
everyone.
All right. Thank you.
Hi, I'm Jia from Zhongguancun Laboratory. Today I'm going to introduce our new draft on ASPA-based ASPAS verification for BGP export. ASPA and ASPA-based verification has been widely recognized as an effective mechanism for prevent root leaks and other similar issues. However, the current verification are only performed at the ingress of eBGP routers, not at the egress. This means that the routes advertised from the local AS are not verified, leaving a potential risk for local route leaks. It is not recommended to use the only to customer attribute to prevent such local route leaks. However, the core issue is that there is a missing for the egress ASPA-based verification. So to address this gap, we propose extending the ASPA-based ASPAS verification to the egress of eBGP routers. This approach can not only prevent route leaks from local AS, but also maintains consistency and simplicity in deployment, as routers could deploy ASPA alone. And we propose an approach for implementation. First, the egress eBGP routers should prepend its own local AS to the received AS path, which ensures the reflection of the route's propagation. And second, the relationship between the local AS and the next hop AS will be used to determine the direction of verification. Specifically, if the local AS is a customer, peer, or as client of the next hop AS, it is recommended to use the upstream verification. And if the local AS is a provider of the next hop AS, it is recommended to use the downstream verification. And it is noted that the eBGP egress router, which is R2 in this figure, it knows the BGP role with the next hop AS, eliminating the need for further transmission. And how to get the relation with the next hop AS? It is recommended to use the local BGP role configurations or its cross-check in the BGP open messages. If these are unavailable, the data registered in ASPA can also be used. And here are some scenarios that egress verification are not necessary. The first is mutual transit. If two AS have a relationship of mutual transit, they may export all kinds of routes to each other, so without violating value-free policy. And the second scenario is when a root server exports to its RS client. At ASX in this figure, the ingress and egress verification are both upstream. So if the verification result of the ingress is not invalid, the result of the egress are not invalid. So the egress verification can be skipped. Okay, that's all about our draft. And we recommend performing ASPA-based ASPAS verification at the egress. It can prevent local AS route leaks, and also routers only need to implement ASPA alone. And this is my first time to introduce our draft, and I really welcome your questions and suggestions. And also, we are actively seeking for collaborators and co-authors. So if you are interested, please contact me to help us improve this draft. Thank you.
Yeah, Krishnaswamy, Cisco. So ASPA verification for the egress, right? That could be an implementation.
We need you to get closer to the mic. We can't hear you.
Sure, sorry. The ASPA verification on the outbound or egress side could be an implementation. Do we really need a draft for it?
Sorry, I didn't hear clearly. Could you say it again?
Yeah. You're able to hear me now? Yeah, the ASPA verification for outbound or an egress could be just an implementation. Do we really need a draft for it? And also in the draft, it is mentioned as a standard track. So yeah, that's something, as a.
He's asking, do we really need to write this down?
ASPA verification for egress has been discussed on the mailing list before, and it is now didn't included in the ASPA verification draft. But I still think it is meaningful to perform egress, so I present it as a separate draft.
Hi, my name is Alexander Azimov, Yango. So first of all, I do agree that what you are proposing is safe in terms of false positives. So you really can apply such a policy on egress and try to detect some root leaks. There are some corner cases that are growing from some complex relationships that may happen on the other side when it was the root was learned by the autonomous system. But the biggest problem, as I see it, that you are saying that we are trying to detect leaks that are happening inside our own autonomous system, right? Right. And but this way of detecting root leaks can't replace the techniques that are using currently because the community or OTC, they are prefix level and they are locally configured. This way of detecting leaks relies on the signing of ASP objects of other parties. So the quality of root leak detection of your own autonomous system will be relying on quality of signing of ASP objects. And so we will be living in a partial deployment state forever. And I don't see how it complements on one side the community-based root leak detection or OTC-based root leak detection. But I don't see scenarios where it can detect more than these technologies.
Okay, for what you said, the issue which is a complex prefix level relationship, which is a challenge that ASPA cannot address. And it is inherent to ASPA. What we do this draft is just to do more in the scope of ASPA, which is just like RFC 8893 do for RPK LV at egress.
I would like you to specify in the draft what we can do with this proposal more in terms of not ASPA, but in terms of operations of their network operations. So what benefits they will get by adopting this technology?
The main benefit it can gain is to prevent the local root leaks, which ASPA cannot do now.
Okay, I will just leave the agree, and so we can talk afterwards. I will just try to clarify the questions.
Okay, thank you.
Sriram.
This is Sriram. Can we go quickly to slide 10, please? Thank you. So, Gia, you're right that the egress verification idea was included in ASP verification draft version 15. However, that was like 2 years ago, and the authors team had a meeting in San Francisco at an IETF, and we decided that we are going to take it out because we recognize that there are problems with doing that. And Alexander already explained to you some of that. And mainly the reason is that there are two cases which I think you also realize. One is when ASN on the left doesn't have an ASPA, then R2 has no way of knowing what is the relationship between ASN to ASX unless R1 sends some kind of an internal message from R1 to R2. And also for the complex case, like Alexander pointed out, the same issue. So because of that, the egress verification doesn't seem like you can make it work. So the only way is to be able to send a community or the OTC attribute internally from R1 to R2. And that's pretty much the only way, because that is on a per prefix basis. If the relationship is complex, even ASPA doesn't help, even if it exists between ASN and ASX. So the only way to solve the problem of, trying to do the egress, preventing the route leak, is having a message go from R1 to R2 regarding the relationship on the left. And like Alexander pointed out, you can do that easily with OTC on a per prefix basis, which is very important. So let's think about this some more and we can discuss it further on the list. Thank you.
Okay, thank you for your detailed comments. And I also have a question, is the low deployment or low registration of ASPA should be discussed in the functional draft? This is my question. Okay, thank you.
Yeah, we first have to make sure that the method you are proposing is sound and workable. There are questions about that, and OTC does a much better job than what you are proposing. And that was also the reason why we removed it, and we thought that we may come back to it later. I'm glad you are doing it. So it gives us an opportunity to discuss it and either dismiss it or keep it. But we can have some more discussion on the list.
Okay, thank you.
Tobias?
Tobias Siewich, Max Planck Institute for Informatics. And I would like to echo along the first comment from the microphone and also the second to previous. This to me sounds a bit more, if at all, like an operational question, and it aligns with some things currently going on in Grow. So like, as you said, it might be local operational choice of the operator, like whether they want to do this or whether they have a case where this is even relevant. So I'm not sure whether SIDROPS is in the right place.
Okay, thank you.
Q Meisel, also Max Planck Institute for Informatics. So I may be failing to understand the purpose of this, but I, as an AS operator, have various contractual relationships with people for transit, period, whatever. The purpose of ASPA, as I understand it, is to advertise these contractual relationships to other people so that they can verify that other people on the internet aren't lying about them. I am the authoritative source of what these are, so I don't quite see what this adds, because I already know what my relationship with everyone I'm peering with is. Why do I have to process a data source for which I am the authoritative source to then do what I could just do with a text file that I load into my router?
Sorry, I know what you said, and maybe I should just think, and maybe I will respond to you later.
Yeah, sure, fine.
Thank you.
Here.
Yeah, I'll keep it short. Kier Patel, Arcus. One of the things that you may want to also think about is the implementation on the protocol side and the scale, as well as other implications as you start to put this kind of policy on the outbound side as opposed to an inbound side, yeah? Something you want to think about. Thank you.
Thank you.
Ben Madison, Work Online. I mean, in the spirit of pretty much everyone else who's commented, I think the problem with this, and the reason that it was dropped from the verification draft a couple of years back, is what ends up happening is in order to do this, what you need is some sort of marking carried with each prefix you've learned in order to determine which algorithm to apply at egress, which means you need communities or OTC or something similar. And you also need local information, like you identified, as to which type of neighbor you're about to advertise this stuff to. So you have locally all of the data that you need in order to apply this sort of a policy. You don't need the presence of ASPAs doesn't add anything. You already have to know, did I receive this path from a peer or a transit or a customer? You already know who you're about to advertise it to. This can be done statically in regular routing policy like it is today. Trying to add ASPAs into this gives us really nothing beyond how operators do this in practice today. And that's basically why it was dropped. What you get from using ASPA here is strictly less useful than what people do today and what you have to carry on doing anyway in order to make this work. So it's just, whilst it's not incorrect, it's what you've identified is correct, it's just not that useful. And that's why it was removed from the ASPA verification draft originally. So whilst I think having this conversation with a wider group is helpful, I'm not sure that this is going to be useful operationally.
Okay, thank you.
RPKI terminology is next.
Hello, everyone. Am I speaking into the mic? I can't hear myself. Yeah.
Or you could move
pick
it
it
up
up.
so you can stand up straight.
I'll just bend over. I want to keep this short anyway. Yeah, no, that's the plan, unless people have many comments, which I doubt, but you know. Yeah, right, yes. Okay, thank you. Yes, no, I'm not that. Okay, well, no, stand up very straight. Okay, so I forgot to put our names on the first slide. I don't look like Zio Jan from CD and Nick, who's actually taking the initiative on this. And so he spoke with Tom Harrison and myself about this idea, and he uploaded a draft with us as co-authors recently. Well, just, you know, the last responsible moment, let's say, and a version 01 just after. So what is this about? I just wanted to give it exposure because you might have seen it on the list, you might not have, and we'd like to draw everybody's attention to this. So RPKI terminology. So the problem perceived is that there is inconsistent and imprecise wording terminology in RFCs, also in documentation and conversations, and from the RAR side, also in the way that we name things in the documentation that we provide. In the DNS space, there is a analogous effort. We have a RFC there that talks about our DNS terminology. And the goal here would be to do essentially something similar, to agree on common terminology, hoping that that will be helpful. Also, include pointers to relevant documents where necessary. So it doesn't replace reading those documents, but it can be a starting point to, you know, understand how it is all tied together. Of course, we have to be a bit careful in the trade-off that if we say, we have to say a bit about how this all works without venturing into any kind of specification language there, because that's certainly not the scope of that this document. The current scope that we're looking at is current RFCs, because that's what we know. Hopefully we can include ASPA related things as well soon. And it's very early days. But yes, we'd like to move forward with this. So we would like to do a call for adoption pretty soon and invite everybody to join the discussion. That's the now long talk.
Questions or concerns?
More of a comment.
Or you could
So-
lower the mic.
Thanks, Russ. Now I can reach it. Warren Kamari, Google. So terminology documents are incredibly boring and incredibly annoying to write and incredibly frustrating to write, but it turns out they're super helpful and super useful. And so like if you're willing to do it, like, wow, thank you. But keep in mind, it's going to be a long time and it's frustrating. The DNS terminology one has been really useful in many ways because people actually now agree on what a word actually means. Or at least they know they don't agree.
Yes, understood. Yeah, I'm not the first author, but I did offer help.
So Tobias Siewich, Max Planck Institute for Informatics. This is basically the RPKI/ASPA subset, like the SIDROPS subset of the terminology document we're also working on in GROW, with the GROW document not trying to be an authoritative source. So I do very much see the place of this document being like authoritative, especially within the development of ASPA and RPKI. So I'm generally a fan. It also makes my document shorter, which is also always good.
Okay, thank you. Randy.
Randy Bush, Arcus, and IJ Research. To Warren's point, if you keep the scope to the actual objects themselves, I think you will keep from going down the rat hole that Warren worries about.
Okay.
I think it would have to be the objects and the entities that process them, right?
Yeah. Well, yeah.
I need a notation to say CA.
I'm asking you why you excluded the entities. A CA is an important thing here.
Yeah, there's CA is fairly well defined, but I don't know, just because that's how I feel. It's Tuesday, it's IETF.
Hello, everyone. I'm Jasdeep Singh from Erin, and I think my co-author Andy Newton is on the back. The title of this presentation is an RDAP extension for RPKI registration data. This work has been adopted in the regex working group, just a quick context. And the suggestion from that working group was that promulgate in the SIDROPS working group. So hence, I'm presenting here. So the motivation, for folks who don't know what RDAP is, it is Registration Data Access Protocol. It's used by regional internet registries and domain name registries to provide access to their resource registration information, whether it is internet number resources or domain names. And so that's what RDAP is. RPKI, of course, this group doesn't need introduction on that. But again, it's to cryptographically assert about the registered internet number resources with the motivation to prevent route hijacks and leaks. I think there are two main reasons why this draft came into being. One was that making RPKI registration data available through RDAP, it could complement existing RPKI diagnostic tools when troubleshooting a route hijack or leak. Obviously, the diagnostic tools are all the way from validators to various walkers through the data itself. Example being that, I'll just give a couple of examples where, let's say you have an origin AS and AS number, and you want to find the ROAs associated. And I stress this is the registration data in various registries. Other example could be that you have provider ASN number, and you want to see what ASPAs it's related with. Beside troubleshooting, the second motivation I think we had was that there has been a precedent of visualizing the RPKI data, whether it is, I think it's now defunct, JDR tool or Cloudflare or some other ways to do that. But the idea was that could RDAP help explore the RPKI hierarchy in a human-friendly way, in a visual fashion, without interacting with the signed objects directly. So this is, again, a complementary motivation. Very important, what it is not, to set the expectations. This extension, I mean RDAP extension, it must not be used to directly influence internet routing. It's a very important sort of goal we have set. Thou shalt not do this. And secondly, not to bash RDAP here, but neither RDAP nor this extension define the necessary security properties or distribution mechanisms required to securely add, remove, or modify internet routes. So we are very clear on that this is a secondary complementary complement to the core RPKI, and hence it's about the registration data. Now, this is RDAP lingo. Without belaboring all the details here, essentially there's an extension, you define certain object classes, and we chose 3 main ones. And by the way, this draft went through with some gracious input from some of the RPKI experts initially, including Job, Tim, sorry guys, I'm naming here, but Tees, for instance. So we picked 3, ROA, ASPA, and X.509 resource certificates. And then search results, how typically in a directory service, the containers for that. And then essentially how to look up and search. And there's another concept called reverse search. And the relationship with IP network, autonomous system number, and entity object classes. So that's the salient feature of this proposal. Sorry, this is a little small, but just wanted to give a flavor of one example. And where when you're searching ASPAs by provider ASN, this is what you'll get back. The bold is autonomous number, AUTNUM, provider AUTNUMs, publication URI, notification URI, the event, in this case, when was it registered, and certain links correlating the ASPA to, in this case, the customer ASN. So the draft status right now, it has been adopted. Some input already there. But the idea was that the working group on the regex side was like that this needs to go through, from correctness angle, couple of RPKI experts to say, yeah, this sounds sound in that sense. So that's why coming here to request further feedback, not instantly, but that's a gate for us. Let me just leave it at that.
You have a long queue.
Thank you.
Tobias.
Sorry, Tobias Siedich, Max Planck Institute of Informatics. Only concern that just popped up. If you explicitly need to say like this should never be used for something, that to me always implies that it could be used for something. And I'm pretty sure that network engineers are not the best readers, at least when it comes to reading things that say like you shouldn't. Yeah, I admire that problem. I'm happy it's not mine, but.
Yes, I think all we can do is just say must not. But to your point, well, so.
Job Snyders. As soon as I find RPKI experts, I'll be sure to send them your way to help. I'll be on the lookout.
Thank you.
Yeah, on the lookout.
In the exam, can you go back 2 slides, please? Yeah. So I take it that not valid before and not valid after are taken from the X509, not before, not after of the underlying ASPA object. Okay, that's cool. What I would recommend you to also include as a data field is the message digest of the underlying object this information is derived from. So if you include something like the SHA-256 base 64 encoded, the nice thing is these objects are not malleable. So they are like guaranteed unique keys that I use to associate derivative products like this would be. So yeah, put the SHA hash in there and that might help somewhere.
Thank you. That's noted. Thanks.
Hi, Ben, Work Online. How do you envisage an instance of this service interacting with the RPKI system?
Sorry? Say again?
So if you imagine, for example, Aaron's RDAP service, do you envisage that service kind of slurping in the whole RPKI hierarchy and exposing all of that data of the whole system via this interface? Or is the idea, do you imagine this being partitioned? So Aaron's RDAP service exposes data related only to Aaron's infrastructure. Have you thought about how that interacts with the delegated instances?
Yes, that's a very interesting question.
I think that's, I've been sitting there thinking about it. I think that ends up being quite complicated to use in practice in a helpful way.
Yeah, so yeah, we actually thought about that. And by the way, there's a GitHub for this where we have been discussing this. So that's a great question. Number one, clearly the RAR, the whole structure, how it is set up. So every RAI have the owners of their own data. Delegated is tricky, as you precisely say. So I think the suggestion, or where we stopped, again, for now, and I think it was Tim's suggestion, was if you see the notification URI, the idea was that that's the closest we come. Slurping is a pretty onerous thing. So at this point, I'm thinking aloud a bit, although we have discussed it, we want to get the core basic thing going first. And then if we can sort of provide for more actors, so no promises here as I'm saying, but we thought that the notification URI is probably one pointer which can tell you, I think Mark even had one idea, which was Mark Foster's, where you could even point to somebody's RDAP service. After all, it is a distributed information system. But yeah, that was where we were scratching our heads a bit. But we thought that for now, let's focus on just the registration data in situ and then go from there.
So my experience of interacting with registration data sources is that it's that distributed nature that makes it annoying. And I think it would be, I think this kind of a tool set, whether it's RDAP based or some kind of other equivalent database, is a useful thing to have if what you're trying to look into is not the cryptographic stuff.
Yes.
I think imposing that same annoyingness on that tool, the RDAP inherits because of the RR organizational system, is kind of unfortunate. I think that needs to be. I think that needs to be a problem that needs to be kind of first-class status in order to make this a useful thing day to day.
So one thought, not to digress, and I won't take too much time. There's a concept in RDEP called RDEP Bootstrap, which is done at the, and some of you may be aware of it at the INA level, but it only has a certain granularity. So let's say we were trying to map that thingy to delegated, for instance, not there, because it all talks about the top level INR objects which are delegated to the registries. But you could even imagine the national internet registries and LARs. So the model could be done, but for now, no. But anyway, so that's where we are.
Okay, Rüdiger.
Rüdiger Volk. I'm struggling to understand. Maybe I missed an important part of your presentation. Is this supposed to work like the RIR grabs all the RPKI information and makes a query interface available for all of it? As we know, in RPKI, there are delegated CAs and all of that stuff. And it kind of, well, okay, doing global searches kind of may require to slurp all the stuff. Or are you essentially proposing something where you want to require all delegated CAs to implement this technology so that it works top-down and recursively like we have been doing the RPKI itself?
That's a great question, Rüdiger. So I stay away from slurping, as I was explaining earlier. But that said, RDEP, no offense, Andy and others, where it's an internet standard right now, standard 95, but the ecosystem is still growing. What I mean by that is in terms of open source implementations. After all, it's a good old web service using JSON and HTTP architecture. But you could envision, Rüdiger, where the delegated side could even bring up their own RDEP server, because in the end, it's a registration data. So the question is, there are registries, and we have a precedence of it in Brazil NIC, for instance, on the LACNIC side, Mexico NIC, and then CN and IN, I think, on the Asian Pacific side. But I think we are not gonna, exclude those folks, but this is not also saying, shoving it down their throat and saying you must, if I'm making sense.
Yes, but if you make it essentially optional participation, how are you supposed to kind of give the global view? If you only give limited view, of course you only get limited value. And kind of for the limited value, I would see the alternative that a few people have been doing RPKI browsers. And as far as I remember, long time ago that I had a look at it, they have been designed in ways so they are going after the true RPKI infrastructure and data structures, and so are not limited to. Yeah, maybe there are extra costs for global queries, but kind of the RPKI has been designed with, well, okay, RPs are supposed to have essentially the full global data available. Right. Because on routers for routing security, you need it.
Right, so bottom line again, this is complementary. And the approach we took is that perfect not be the enemy of good. And for now, that's where we are.
Tim?
Yep, Tim Rijsels from NCC. Yes, I think I actually suggested slurping as well. but it depends where you want to go with this, I suppose. Because on the one hand, this kind of API, if you will, could also be exposed by RPKI validators and perhaps be useful there. On the other hand, this is, if it's about registration data and showing potential differences between what you see in registration data and what we see in the actual RPKI when we validate, then it becomes a different story. And maybe there, this has a role to play. But I do think you need to be clear on that when things are missing here, it doesn't mean that they don't exist in RPKI.
And
that needs to be really clear to users.
Yeah.
So any result like this does not exist, I would be careful about.
Correct. And I think we should probably upfront set that expectation.
Q Meisel, Max Planck Informatics. I can see three main ways of this being used. One is, here is an RDAP repository that also has an RPKI repository connected, like the RIPE NCC hosted RPKI. And then you say, okay, here's all the stuff as per whatever I know about in this connected repository. The second way is, here's all the stuff I know about and all the stuff in the delegations further down, which then requires quite a bit of processing. Or this is something implemented by a relying party to say, oh, give me all the ASPers for this AS. And I'm not quite sure what it would be nice to be clear in the draft which one of these, or maybe a secret fourth option, you're trying to achieve. And if it is the first case of this is an RDAP repository specifically connected to one RPKI CA or CA operator, then we also need some way to delegate within RDAP, like, oh, these ASs are delegated to this RPKI operator, go ask that.
Right. Thank you, Q. So clearly, it's the actors you're looking at. So it's certainly we are starting with the registries. And delegated, I think it has come through a lot of speakers and something we also preemptively thought about it. So as RPKI expands, this is hopefully, and RDAP is not also there if you think about port 43 right now, right? That's still 90% of the traffic. Yeah, but we'll keep that in mind. So thanks.
Andy?
Andy Newton, one of the co-authors. So whether an RIR slurps all the data in or not, I think is really kind of up to the RIR. But this can be designed in such a way where someone, an entity, slurps all the data and then can say, here's what I have. But if you want to go check someone else, I'm going to point you to that correct place. It's called a referral. That doesn't happen in the IP space a lot with RDAP, but it does happen in the domain space. So we could definitely do that. Randy Bush and Rob Austin actually brought up something in the chat, which I thought was very interesting, which is about Ghostbuster records. So it's probably something we need to think about.
Keep it short, please.
Short.
Oh, come on. Okay, thank you.
Thank you. Thanks.
Thank you. Hello, everyone. I'm Minlin Jia from Tsinghua University, and today I will present our work on source address validation with source orange authorizations. It was done with Gangren and Xia-Ying. Here's the outline. First, I will introduce the source address protection service, or SAPS, and its difference with source address validation. Then I will explain why SAPS needs RPKI and how it uses RPKI. Finally, I will briefly discuss the effectiveness and cost of this approach. In SAV, every AS checks all incoming packets, but in SAPS, only service providers perform validation, and they only validate packets if the source address of the packet belongs to their service subscribers. So why do we need SAPs? It's a solution that seems weaker than traditional SAP. First, consider who suffered. First, consider who suffered most from IP spoofing. In attacks like reflection-based amplification, the victim is often the true IP owner of the spoofed IP, not the network receiving the traffic. And tracing spoofed attacks can also wrongly implicate the innocent real IP owners. Therefore, IP owners have a strong incentive to filter traffic that spoofs their IP addresses. Second, precise SAV often requires collaboration with the true IP owner because we need reliable routing information about expected traffic path or characteristics, and we can only get that from the true IP owner. Finally, SAV mechanisms may mistakenly block legitimate traffic. For many networks, this is worse than occasionally spoofing. So by filtering only packets with source addresses from those who request protection, SAPs offer a more practical and targeted solution. SAPs also faces some challenges. First, SAPs requires a global service discovery platform to identify who can provide protection and who needs it. Building such a system is costly. Second, building trust between ASs is essential. Since SAPs needs inter-AS collaboration, networks must trust each other, and establishing this trust in decentralized environment is challenging. Finally, secure route information transport is crucial. Validation related data must be protected to prevent tampering. And a secure and a verifiable mechanism is needed to stop attackers from injecting this information. So as we all know, RPKI offers several key features that makes it a strong foundation for SAPs. First, RPKI is designed to operate on a global scale, ensuring that validation can be applied across all ASs. Next, RPKI is open to all, ensuring any AS can participate in the service. Then with CA certificates, RPKI ensures the identities of participating entities are trustworthy. Finally, the information with RPKI objects, such as ROAs, is verifiable and cannot be tampered with, ensuring its integrity. These features makes RPKI well suited for addressing SAP's challenges. Next, I will explain how SAPs leverage RPKI to implement source address validation. A source origin authorization, also called SOA, is a new RPKI object designed for source address validation. It is issued by the AS owning an IP prefix block, similar to ROA, and it authorizes an AS to send packets with a source address belonging to the IP owner. The content of an SOA includes the following fields: the subscriber AS, which is the AS requesting protection; the provider AS, which is the AS we want its protection; and the destination IP, which is optional, means we only need to filter traffic to or toward this destination. Legitimate preceding AS length and its list. That's the core, which are the AS that packet should pass through just before reaching the provider AS. Next, I will explain what an AS should do when it wants to request or offer protection services. If an AS wants to become a service subscriber, it should follow this. First, choose a provider based on factors like AS rank, reputation, and past behavior. Then, use BGP routing table data to identify the legitimate preceding AS for its traffic path. After that, it creates the SOA and stores it in RPKI. Next, I will explain what an AS should do when it wants to become a protection provider. First, it queries RPKI repository for SOA where it is listed as the provider AS. Then it retrieves the information about subscriber AS and the list of legitimate preceding AS from the SOAs. Next, it deploys filtering rules to ensure that the packets with source address belonging to the subscriber can only pass through the specific legitimate preceding ASs, and detailed implementation are provided in document. It assumes that ASs requesting SAPs also have deployed ROAs because we need to find IP prefixes by ROAs of the subscriber, so it can also push ROA deployment forward. Next, I will discuss the effectiveness and cost of SAPs. SAP's effectiveness depends largely on the number and the placement of service providers. Simulations show that with about 100 providers deployed, there is roughly one valid provider per random attack path. The cost of SAPs involves several factors. The first is RPKI storage. The total number of SOA is calculated as the number of subscribers multiplied by number of provider ASs. And the size of each SOA object depends on the average number of legitimate preceding ASs. And as more subscriber requests, ACL usage grows. But the increased use of ACL also brings greater benefits, and that could be used to update devices for larger capacity, so it is acceptable. And that concludes my presentation. Thank you for any comments and your attention. Thank you.
Tobias.
So Tobias Hübich, Max Planck Institute for Informatics, and I'm a simple person liking simple things. That's why I do DNS and BGP. It's fine. I personally feel a bit confused by SOAS, which as an acronym is a bit of an overlap with DNS work. That is more like a NIT, but something which might be worth considering. And complexity then indeed is the other thing. So to me, it does not really become clear from the document and the presentation how the relationship between the complexity of the proposal correlates with the protection guarantees it can provide.
You mean the relationship with,
It is very complex. And I don't know whether the protection it can provide with that complexity is worth accepting the complexity.
Algorithm complexity?
Operational complexity, yes.
That is how it uses the RPKI storage?
He means operational complexity.
Operation complexity. Yeah. I think that's about equal with our ROA, because we want to compute and store it, and the provider should retrieve it and get the information. I think that's similar. And other operations, we will use the netconf and the BMP. Yeah. Which that one?
Lan Cheng from Zhongguancun Lab.
Thank you.
It seems that this object is only useful to the service providers, so other ASs cannot use this object to perform SAP.
Yeah, that's right.
Yeah, so I'm not sure if it's really needed to register such information in a third-party database. So maybe the service subscriber can directly provide such information to the service providers.
That's right, but there are two problems. The one is if we translate it one-to-one, there will be many connections and we don't have a protocol like this. And another one is, I don't know if the provider wants to help me, so I just put it in the RPKI and the provider will find it later, maybe sometime, and it uses it. Yeah, thank you.
Jeff?
Jeff has.
I wish to first make sure I understand the proposal correctly. A SOA says that for this AOS, here is the set of destinations I'm willing to forward to.
Yeah.
From the source.
Yeah.
So
you need my explain for that?
Is my understanding correct?
Yeah, that's correct.
This is terrifying.
Why?
The reason why it is terrifying is because this state is in response to routing. Routing will send you destinations that try to attract traffic for destinations.
Yes.
And there are mechanisms that you use to filter routes. RPKI is used to validate routes. The IRR database from RPSL is used to filter routes, these sorts of things. But once you've accepted a route, the contract that you have is that you're to forward traffic to them. What this mechanism tries to do is a router that receives some route to attract traffic, you are saying, I'm not going to try to track that traffic. I might actually have this installed in my routing table, in my fib, but you're now firewalling using this mechanism from me being able to potentially get there. And with these two pieces not fully in harmony with each other, you can end up with terrible cases where you just black hole everything because this relatively static database does not match the very dynamic routing.
The two conditions are and relationships. With the destination IP, I also need the source address to belong to that AS. Yeah, the two conditions are relationships. So it won't cause any traffic toward that IP blocked, only originated from that AS. Yeah,
I believe I
It's
understand.
additional.
And restating your proposal somewhat, this is a way for an AS to firewall destinations. I don't know if that's what we want to use our PKI for.
Yeah, I wanted when a big server like DNS or NTP server is used for amplification attack, and we can only set an SOA for that server to protect it from many spoofed traffics. That is what I mean.
Yes, I think you're going to find this information is for your use case too dynamic for this database.
Okay, thank you.
Max Planck Informatics. In a somewhat rephrasing of what Tobias said, this seems very complicated for very little value. If you want, part of getting something through the IETF is that other people actually have an interest in deploying this. And speaking as an operator, I don't see the value for me in deploying this for the complexity that it places on me. And I think this could either be helped by simplifying this or further motivating why I would want to use this. I'm not expecting a coherent answer now, but maybe in the next version, put some more work into motivating why an operator should go to the effort of implementing this.
You mean become a subscriber or provider?
Or just why should I put effort into writing the code to implement this? It just seems like a lot of complexity for an unclear value.
To become a subscriber, we can prevent the traffic that spoofs our IP addresses. And to become a provider, we can ask for service fees for the subscribers. I mean, that's it. Thank you.
Ben?
Ben Madison, Work Online. I'm quite confused by the whole thing. I think I understand how the mechanics work. But I think the thing that I'm finding the most confusing is, so the last point on your current slide, if you go back to where you were, that final slide,
Which one?
other direction, back to the end.
Oh, back to the end.
Yeah. Yeah. Higher ACL usage increases profit. That's not something that I've found to be true.
I mean, if we provide more.
I
So
that was probably
others.
not meant for you.
I don't understand what the RPKI object is essentially a signal to the community of service providers that I want you to do some sort of filtering of traffic that has my prefix in the source address.
Yeah.
What I don't understand where the incentive to do that for the provider comes from.
A provider. That's
There's no commercial relationship that arises out of creating a signed object in the RPKI. No one's being paid in this mechanism anywhere that I can understand.
Yeah, you got that. That's a thing I didn't mention implicitly because that's called a service. So a service needs the provider, the subscriber to give some fees to the provider.
So you said a minute ago in response to one of the other questions that you didn't want to impose the requirement for there to be any bilateral communication between subscriber and provider. But
Maybe
that's
we can
necessary. If someone's going to get paid, then there needs to be. I mean, I don't understand how this is more useful than a phone call and a contract that says you'll do this thing and I'll pay you each month.
Yeah, that's a
which is a perfectly valid arrangement to enter into, but you just don't need any of the crypto or any of the publication or frankly the specification to do that. That's a bilateral arrangement between adults.
Yes.
If that's the basis on which this operates, then I just don't think that it's.
Yeah,
I just don't think that it's
add
sound.
that to the next version.
Okay.
Thank you.
Kier, please keep it short.
Yeah, I just want to, Kier Patel Arcus, I just want to clarify that I am following this proposal, that this can't be routes. So that last line implies that when you look at the router, you are creating ACLs. And what you are trying to say is that, hey, this ACLs can be somehow monetizable.
Yes.
Okay.
Okay, it should be more clear for that. Thank you.
Okay, next is forwarding commitments.
Sorry. Hello, I'm Yang Guo from Zhonggan's laboratory. Today, my topic is about using forwarding commitments to describe routing intents. I know you may have heard FCBDP, but that is not part of FCBDP mechanism. Okay. So let's recap BGP model. The basic BGP route propagation pattern is the AS receive routes from previous AS and access them. And after that, it will advertise routes to next AS according to local routing policy. So there are only 3 AS are involved in this pattern. The previous AS, it can be null because the ASC, it is the local AS, can be the originator. And second is the local AS. It is maybe the processor or the issuer. And the next AS, it can also be null, as the local AS can be the terminator of the BGP propagation. So our goal is about to detect route propagation that violates local routing intent and verify the validity of BGP AS paths. We have analyzed existing mechanisms. BPSec is an unpassed AS path forwarding mechanism to detect for detection and provision. it is costly and the prefix cannot aggregate. It means one prefix needs one update. And ODC and the BGP roles are path attributes. It aims for route leak prevention, but it is not authenticated. RA and the standard prefix list are for prefix origin validation. And the ASPA and ASRA, they are relying on business relationship. They are cross-grained. So shall we design a low-cost, fine-grained and authenticated AS password protection mechanism? Here, low-cost means that verification has been uploaded to the validator, not in the router. And fine-grained, it means that different route origin can traverse different paths. And authenticated means that no one can force to modify others' routing intent information. So we would like to propose FC signed object in RTCAD. Here is the FC's profile. The ASD, the ASID, the version is 0 as the default value. ASID is the local AS number. It is the issuer's AS number. The most important field is the routing contents, intents, sorry. Routing intents is a description of the routing intents. It means that when the local AS, that is the issuer, receives the route from previous AS and send it to the next hop AS. So routing intent is a list of routing intents of one AS. The previous is the previous AS field is the upstream AS. If it is none, it means that local AS is originator of the routes. And the next hop AS are the downstream AS. If it is none, it means local AS is the terminator of the routes. Origin AS is, it refers to the RA and SPL. So we use this sign object to bind the RA SPL or SPL with the route path. When the default value of origin AS is none, it means all routes received from previous AS list can be sent to next hop AS list. So the verification result of FC sandbag object has 4 states. It is a totally valid state, unknown state, and invalid state. We propose a totally valid state. Sorry. Okay. I will show you each of these states. Totally valid state means that each AS in AS path has FC, and each FC's origin AS field is specified as this picture shows. And valid means that valid state means that each AS in AS path has FC, but some FC's origin AS fields are none. None here means for any. Or the originator doesn't issue RA or SPL. That's like the picture shows. S2 and S4 doesn't specify the RA, but it has the default FC for this route. And the unknown state means that now as in S path has FC, it is clearly. And invalid state means that some AS in AS path doesn't have FC. Just like the picture shows, S2 doesn't have an FC for this route.
We're running out of time, so I suggest you talk to some of your,
Sorry?
you have a long line and you're almost out of time.
Landline?
Long line of people who want to ask questions.
Okay.
Tobias?
So Tobias Jülich, Max Planck Institute for Informatics, and I would basically echo like the previous comment on complexity, also in terms of overhead and what a full deployment of the solution would do in terms of size of data to be synced into the RPKI. Because it feels like we are close to like putting all tables of all ASs into that data set.
Sriram?
Sriram, quickly.
This is Sriram, NIST. Do I understand it correctly that these forward commitment objects are attesting they're sort of attesting in the upward direction from customers towards the provider? So, for instance, if I am an AS, I would attest who are my downstreams, my customer ASs, and who are my upstreams, the provider ASs. Is that correct, or is it in each direction? For example, if I'm an AS, I take the full table from my provider and then send a full table to my customer. For that also, do I create the FC object separately?
I answer after that in the knowledge. Okay, thank you.
Okay, never mind. I can put. I mean, I have several critical questions about this proposal. I will share them on the list.
Thank you.
Thank you.
Jeff?
Yes, and maybe answering for the speaker, Sriram, this is directional. My question to you is, are you familiar with RPSL, RFC 2622?
2622.
And if the answer is no,
Yes.
you are effectively recreating a policy object from that called autnum. I will post to the chat so you can look at it. You have incompletely reinvented autnum for RPKI. This is not bad. This is first start. The origin ASs field that you have is a small list. What you're going to find is the desired filtering semantic is, from list to list, and then an AS cone for the set of things covered. And this is normally covered in RPSL by a mechanism called AS sets, which there are people within the SIDR Ops group that are looking to provide AS sets in RPKI. So you may wish to review this mechanism and perhaps discuss with them about integrating it with your proposal.
Okay, thank you.
Alexander, you're the last one for this.
May I ask you to go a few slides back when you are describing the embedded scenario?
Oh, I took back control. Which one do you want?
Yes, this one. One slide ahead.
That
yes. Yeah. So, am I right that in partial deployment state you will mark routes as embedded, or have I was confused?
Yes, that's kind in partial deployment.
So, and the problem is that we will be always in a state of partial deployment, and according to your draft, in all embeddeds are illegible for route selection. I believe it's a kind of a problem here.
Okay.
Thank you.
Okay, we're almost out of time. We're going to try and get one more presentation in.
So I have to go really fast, right?
Yes.
Okay.
Yes, you do.
This is Dima. This is Dima, work for ZDS. Sorry. Next slide.
I'm sorry, I got to give you the clicker. There you go.
I'm going to introduce efforts by my team about the consideration and practice on RPK reliant party deployment. So we all know what is reliant party about. Why bother to do this? Because as I always mention to colleagues in the community, that a set of standardization could be a mighty guide, but not a prerequisite for success in deployment. So I think it's necessary for us to map the logic function of the reliant party to physical nodes over networks. Okay, this is straightforward. We establish a distributed system that with a set of RP synchronization nodes and a single console node. And the synchronization node is functioned to, the console node. Okay, the console node is functioned to scan all the publication points and to see what if to see if there are any updates from the publication points, and to allocate the synchronization task to a specific nodes or one or more nodes to do that respectively and validate that. So I'm not going to dive into the details of the internal structure of the console node, but anyway, there should be some modules interfacing with each other to do that. Okay, this is straightforward. I'm going to skip this. So there are 6 algorithms used by this RP in various scenarios to meet some specific operational requirements as listed here. And in a separate academic paper, my team did analysis of all those algorithms to see whether they can work. Anyway, those scheduling algorithms are optional to the operator in its discretion according to local policy. Okay, here's the current deployments. This RP, the console node of this RP is located in Beijing, and we have got some synchronized nodes deployed in Cairo in Egypt, Peking, Singapore, San Francisco, Sao Paulo, and Frankfurt. Okay, with respect to different IR regions. Okay, clarification. So this is an information document that provides current practice deploying RP system of networks. And we are not going to bring any extra technical requirements that need to be standardized by IETF. And anyway, we hope this could be adopted that can bring more discussions on reliant party software or system deployment in CDN provider and large-scale ISP worldwide. That's
we have 2 minutes
what
left.
I have.
We have 2 minutes left in the session. Does anyone have questions for Doc?
Before you start, just a quick note. Please make the adoption request on the mailing list.
I'm trying
Go
to.
ahead. Don't waste the minute.
All right. If you go back 2 slides, you had a few algorithms how to distribute the work. The only viable algorithm, I think, is random task assignment, because there also is a security consideration in that the list of things to be fetched from the nodes distributed around the world partially is third-party supplied information, and it doesn't have semantic meaning. So to not give any third party any type of leverage, only random task assignment works well in this particular environment. And this was already implemented in our PKI clients and Fort for where the collection is, of course, not local, not distributed like you proposed. But I think that the same reasoning why in a local context the order should be random task assignment also applies to your mechanism. Just, it's nice to have multiple algorithms, but I would go for random.
Thank you.
And we are out of time. So we got through all but one of the presentations.
Can you give me
We're out of time.
30 more seconds? Just
An advertisement. All right, very quick.
Just 30 seconds. Could you?
We're already over time.
Okay. So hello everyone. I'm Shuhe Wang from Zhongguancun, and actually I'm going to be talking about. Can you show just the cover of my slide? Thank you. Yeah, thank you. Just the cover of my slide. Okay, so I'm going to be talking about this topic, and actually this topic, I'm also going to present this topic in Thursday at the Grow session. So if you really have some interest and if you have some question, you can talk with me through the email, or you can listen to me at Thursday at the Grow session. And thank you.
Thank you. All right, we are done. Thank you, Jeff, for the notes.